In this video, we are going to describe polar coordinates. In two dimension, I can describe the position of an object using the Cartesian coordinates. So if I take a point P, I can find position of point P by drawing the x and y axis. And then we can find how much we move along the x-axis and how much we move along the y-axis to reach point P. So this x and y values are called the Cartesian coordinates. Now, what are the other ways of finding the position of point P? Let's say instead of going separately along the x-axis and along the y-axis to reach point P, imagine I take a rope and form a direct path from the origin to point P. Now this becomes my radius vector r. And this radius vector describes how far the object is from the origin. Now, in order to define the position of point P, I don't just need to know how far I must throw this rope. I also need to know in what direction I must throw it. So this brings in the need for the angle theta. So theta tells me at what angle is point P located from the positive x-axis. And this combination of r and theta becomes your polar coordinates. We use polar coordinates to define position of an object in circular motion. So for objects moving along a circular path, the radius vector r does not change in magnitude. The magnitude of r remains constant, but the angle r makes with positive x-axis changes as the object moves along the circular path. So when we are talking about the polar coordinate, if you want to find position of an object along a circular path of fixed radius, the value of r will remain the same, it will not change, but the angle theta will change depending on the position of the object along the circular path. So you can relate the polar coordinate and the Cartesian coordinate using the expression. For r, we write r equals square root x squared plus y squared, because r is nothing but the resultant of x and y. How much we move along x-axis and how much we move along y-axis, the combined result of those two is the vector r. And then we can find the angle theta as tan inverse y over x. Theta is always measured counterclockwise from the positive x-axis. So these are polar coordinate in terms of Cartesian coordinate. We can show the inverse relationship as x equals r cosine theta and y equals r sine theta. So this is how you find polar coordinates r and theta with the help of Cartesian coordinate or Cartesian coordinate from polar coordinates. Let us solve some problems using the expressions we just discussed. Example 9.1, locating a point with Cartesian and polar coordinates. A point has a location given in Cartesian coordinate as 4, 3. So this is my x value and y value. How do we represent the position of this point in polar coordinates? So representing position of a point in polar coordinate means finding the value of r and theta. So we just learned how to calculate r. R is given as square root x squared plus y squared. Here the x component is 4, so we do 4 squared plus y component is 3, so 3 squared. And when you solve this, you get the radius vector r as 5. There is no unit given over here, so I'm just going to write it as 5. Then we find the angle theta. Theta is tan inverse of y over x. So we write tan inverse of 3 over 4. And after solving, we get theta as 36.86 degree. Now this is theta in degree. You can convert this to theta in radian By multiplying this answer 36.86 with pi over 180, and that gives me theta in radian as 0.64 radian. So now we can write our polar coordinates as r comma theta to be equal to 5 comma 36.86. This is in degree. Or if you want to write the same thing in radian, you can write 5 comma 0.64 radian. Let's take another example. A point has location given in Cartesian coordinate as 12 comma 5. So this is my x value and this is y. What does this point represent in the polar coordinates? So again, if they are asking you points in polar coordinates, that means we need to find what is r comma theta. R is given as square root x squared plus y squared. So we substitute the value of x is 12, 12 squared plus y, which is 5. And when you solve this, you get the value of r as 13. Then we find the angle theta. Theta is tan inverse y over x. So tan inverse of 5 over 12. That gives you the angle theta as 22.6 degree. Now this is theta in degree. We can convert this to radian by multiplying 22.6 with pi over 180. And when you solve this, you get theta in radian as 0.39 radian. You can also find the angle theta in radian using your calculator by changing the mode of your calculator from degree to radian. And that will give you the same answer. Then we write our final answer as r comma theta equals 13 comma 22.6 degree, or the same thing you can write in radian as 13 comma 0.39 radian. So this is how you convert Cartesian coordinate to polar coordinate. Next we discuss what is arc length. So arc length is the distance between 2 points along the section of a curve. So if I have an object which is moving along a circular path and it goes from position A to position B. The distance it covers from A to B along the curve. This distance here is called the arc length. An arc length is generally represented by the letter S. And we calculate arc length by multiplying the radius r with the angle theta. So theta is this angle between the 2 points here. So let's take an example to calculate the arc length. Suppose if I have an object moving along a circular path and it moves from point A to point P. Let this be point P. The radius of the circular path, let's say, is 4 meters. And the angular displacement going from A to B is 60 degrees. I need to find what is the arc length. Now, when you're measuring the arc length, the angle theta that you take here has to be in radian. So if in the question they give you theta in degree, you need to first convert that theta from degree to radian and then solve for arc length. So let us first write down what is given to us in this question. I have the radius to be equal to 4 meters. The angle theta is 60 degrees. First convert your theta from degree to radian. So I will write this as 60 times pi over 180. That gives me the theta in radian to be pi by 3 radian. Now I will use the equation for arc length to find the distance between the 2 points. So arc length S is r times theta. R is 4 meters. Theta in radian is pi by 3. And when you solve this, you get your arc length as 4.18 meters, which is approximately 4.2 meters.